Hello, hello. Okay, it's working now. Good morning, everybody. So we are going to continue the workshop, and right now we are running a pretty interesting event. We call it the Minute Madness presentations. So basically, the main idea is that all the accepted papers, including abstracts and the shared tasks, they have around 1 minute to deliver to you an elevator pitch of their work, because maybe some of you won't be able to attend all the sessions. So at least you will have a rough idea of all the accepted papers this time. So please, I will just ask to give one big round of applause at the end of all presentations, because the slides will run automatically one by one by one by one by one. So then the presenters, they will line up in here and deliver the pitch and so on, right? There might be some presenters that they are not with us at the moment. So if no one jumps in after some 10 seconds, I will just skip to the next one. Okay? All right. So this is the slideshow. Basically, we have 6 sessions. All of those are showed in the program. So we have session 1, 4 papers. Last one was awarded as an outstanding paper. Session 2, we have 4 papers. So session 1 and 2 will be run today. Then tomorrow we will have session 3. Also, the third one was awarded as best paper. You should try to check that work. Very interesting. Session 4, we have 5 papers. Session 5, we have 5 papers. And then last one will be the shared task. We have 3 papers. Okay, so presenters, are you ready? So I'm just going to, you can pick one mic here, it's on. And we will start in 5.
Right, wait for my slide. So I'm sure many of you are familiar with this situation, both as teachers and as students. The typical lecture tutorial structure is flawed and missing one key aspect. How can we find out how much each individual student actually knows and what their learning progress is? Students' needs are very diverse, and it's hard for a single teacher to focus on every single one of them. So we need to somehow clue these teachers in as to the individual progress of each student, such that they can become better teachers and capable of catering to any student possible. And so how do we actually find out what the student knows? The idea is that a student has a conversation with an LLM. So this LLM is informed by the lecture content, and the LLM acts as the sort of intermediary between the student and the educator. And so the conversation between the two gets sent to the educator, where they can not only figure out the individual progress of each student and also the class as a whole. And then from this, we can gauge important metrics such as how much the student actually recalled from the lecture.
Yeah. Hi everyone. Hi everyone, I am here from University of Sydney. I want to introduce my research, which is text-to visualization. It's the task that receives a natural language request, plotting data, and the system will generate the code that produces the visualization image. A system like this will have the user to visualize the data without programming language or visualization expertise. Our motivation is to create a new benchmark for this task, because in previous research, we found that the benchmarks for this task is not aligned with the real world data sets. So we will collect the data in multiple sources like GitHub archives, data analytics websites. And we also develop an annotation framework for non-expert workers to reduce the cost and to extend the data more effectively. So we will the annotator will annotate the explanation rather than the code. Yeah, this is the main idea of the annotation framework. Thank you so much.
Hello. Today, LLMs perform really well on coding tasks. For example, you can ask an LLM how to do a plot. But what happens if I tell the LLM to do a plot several times? Or if someone across the world asks the same question, will its answer be more creative than mine, or will it be the same? So we try to answer this first by through a survey, capturing people perception on creativity and visual accessibility. And second, by also gathering metrics for evaluating visual accessibility. This is because today LLMs not only need to maintain accuracy, but also be aware of human-centered factors. Thank you.
We'll just wait for the slides, I guess. 4, 3, 2, 1. Okay, so my paper investigates LLM collaborating with symbolic solvers to handle logical reasoning tasks. So we know that LLM on its own is flawed. It hallucinates. It doesn't handle logic really well. The recent approaches has been using different symbolic solvers like Z3 and Prover 9. But the problem is there's over 12 combinations out there, and each paper has their own combination. We don't know which one's the best. So my paper investigates this. So apparently they matter. So there's up to 50%, through experiment, we uncover up to 50% variations in performance based solely on solver selections. So this highlights that solver compatibility, especially LLM's ability, to translate into the solver-specific language matters. So we do need to choose our solvers carefully. Thank you.
Have you ever wondered how hospitals handle millions of documents each year for insurance billing? Well, this is done through a process called clinical coding, where specific codes are assigned to represent diagnoses and procedures. However, label comes with a cost, and manual clinical coding is both time-consuming and error-prone. Therefore, we propose an interactive machine learning-based solution. Specifically, the model reads clinical documentation and predicts a code. After each prediction, the model receives feedback from human experts, which is then used as input for subsequent predictions. The main objective is to refine code prediction at real time and improve user trust through learning through user engagement, which is essential for clinical application. Thank you.
So healthcare systems sometimes really want to customize their own models to achieve optimal performance for their patient cohorts, for the specific demographic distributions. But one obstacle is that they often have limited data to do that. And because of regulation and patient privacies, sharing data across healthcare institutions is really challenging. So one solution is to create synthetic clinical text to help address these challenges to train better clinical models for specific healthcare systems. And instead of asking LLMs to generate clinical text from scratch, we explore this method to rephrase clinical notes and to generate this text and to help pre-train downstream clinical language models. And we explore to use this rephrased clinical text to train both decoders and encoders, and it shows that it turns out it can do a pretty good performance and with a very limited token budget. Okay, thank you.
Have you ever encountered a lung cancer patient, and what would be the first question you ask them? A very typical question that most people ask would be, have you ever smoked? But that is actually a stigmatized question because it implicitly associates the smoking behavior with their lung cancer. And this would add mental health burdens to lung cancer patients and worsening their already challenging situation. So, can we identify stigma-related content online and enhance our understanding and knowledge of this field? The answer is yes. We found that unsupervised NLP techniques can help extract stigma-related information from online forums. What we did was we used sentence embedding and compared the cosine similarities between online discussions and lung cancer stigma skills and found stigma-related content. And we also identified information related to support.
Thank you. I'm Jordi, presenting on behalf of my team. Have you ever been in a situation where you were wondering what your legal rights are, and then you try to search for information and you realize the information is too confusing to read, and then you think of asking a lawyer, but then you don't know what to ask the lawyer, and also it costs too much and it's too much effort to make an appointment. So what we're doing is that we are applying large language models, advances in large language models, to help to lower that barrier of entry to understanding the law in Australia. This benefits both the general public and also first-year law students who are sort of trying to get their understanding in with the law. It also helps lawyers to engage with their clients as well. We use retrieval augmented generation RAG to help to ground the LLMs using authoritative truth of legal text, which reduces hallucination and also reduces the opacity issues that legal community have objected to. Thank you.
Hi. So basically our paper is related to LLM evaluation too, but it's not in the title. So yeah, hate speech detection is quite important for ensuring safe space for LGBTQ plus people online. And increasingly, we're starting to use more LLMs in hate speech detection. The problem is like LLMs might not be able to accurately understand like niche terminologies. So we want to examine like whether LGBTQ terminologies will be flagged and stuff. So this is one example. The word anal something is understood as big bus in Italian. In this one example, that's because like they don't understand the Northern Italian slang. Yeah, that's pretty much it. Thank you. Sorry, I forgot I have another paper as well. So here we're evaluating satire in multilingual context, and we're also looking at the effect of applying chain of thought reasoning on the evaluation process. And specifically, we're looking at JChat model, which is Arabic, which is trained on Arabic and English, and Llama, which is multilingual but not trained on Arabic. And this is our pipeline. Mainly our result is that the JChat benefit extremely from chain of thought reasoning, but for Llama, it doesn't really benefit that much from chain of thought reasoning. We also try varying like different language of the prompt, and funnily enough, Llama is not affected by the language of the prompt at all. And also, even though Llama was not trained on Arabic text, it is able to like classify satire on Arabic quite accurately, probably because there's like some Arabic leakage in the data set. Yeah, thank you.
Hi, everyone. So when you learn a new language, you often find words you don't know, and then getting example sentences for these words is very useful to understand how to use them in context. So I like to find new words on TikTok, and I like to use ChatGPT to generate sentences, and I'm trying to get a paper out of this. We set up an experiment where we generate example sentences in French, Indonesian, and Tetun, 3 languages of different resource levels, using different LLMs, and then we annotate them against a framework called GDEX, which means sentences should be typical, intelligible, and informative to be good examples. And we find that the quality of the generated sentences degrades with the language resource level, which is expected. So good sentences in French, medium good in Indonesian, and pretty bad sentences in Tetun. But more importantly, we find that people don't agree with each other about what makes for a good example sentence. And so linguists very much will tell you this. And we find that LLMs are actually promising to align themselves with one particular person's preference about what constitutes a good example. Thank you.
Is the author here or online? No. Okay, we are going to skip.
Hi, everyone. So semantic plausibility is an important variable in linguistics because it relates to the knowledge of how likely events are to take place in the real world. With NLP systems, it is usually evaluated by a comparison of minimal pairs, where an NLP system has to indicate which one corresponds to the most plausible event. An obvious approach consists of estimating the log likelihood of the two probability of the two sentences and picking the most likely one. However, we wanted to see if we can simply prompt an LLM and improve over traditional log probabilities. And we also wanted to see if instruction tuning improves over a base LLM. We found out that log probability measurements at the end are more reliable for assessing plausibility, and that instruction tuning does not improve the alignment with human judgments. Thank you.
Document level-based sentiment and analysis is very common text classification task. Usually, the text representation is fixed as a high-dimensional representation, and the sentiment signal are hard to locate. In our proposed method, we represented the text review in a raster domain with 5 aspect sentiment score. For the restaurant, they have the food location servers and the ambience and the drink. This is the overall framework of this proposed method. They mainly consist of two stages. One is for the imputation. The other one is for the feature scaling. After these two stage process, we will have a long dimension and explainable representation for text review. Thank you.
Close to the wall. So slow. Okay. Cheers. So right now we have these models like Qwen2 Maths and DeepSeek Code that are really good at a specific domain. But the fundamental issue with these models is they're not very good generally. So things like Qwen 2.5 Maths is state of the art in maths, but it's not very good at, say, writing poetry. So our research was about how do we combine these domain specific models together in some kind of way where we can maintain the domain specific performance with the general skills of these models. So essentially what we do is we take a router and then based on the prompt, we route it to which model we think is most appropriate for a given prompt. And essentially what we're able to demonstrate is that we get state-of-the-art performance, not only domain-specific benchmarks like math and GSM&K, but also in these general purpose benchmarks like MLU and GPQA. Cheers.
Hi, I'm Mustafa. I'm from the University of Adelaide. So have you ever tried finding a venue and felt like you were decoding hieroglyphics? Same. So ASA Community's free text summaries were a hot mess. Enter our Roberto-powered wizardry, where we whip those unruly texts into mark-compliant shape. Think of it as teaching a robot to read between the lines, like literally. So Google Analytics called and people wanted venues. We were hitting 78% accuracy, proving Roberto's got the chops. Now venue hunters can chill while our model handles the chaos. Final note, if Mark Standards had a fan club, we'd be running it. Thank you.
Okay, hi everyone. So I'm Lewis Mitchell from the University of Adelaide. I'm talking about Josh Watt's master's project. The pitch for this talk is we tried to build Cambridge Analytica, but for Twitter and with a different personality model. That's it. We didn't quite get there. I'll tell you a little bit more. We did learn a bunch of things about social media users on Twitter in the meantime. We collected a really interesting data set of people who self-report this, their personality types on Twitter, which is mad. And then we built some models out of it, which I'll show you. And we learned some interesting things in the process. So come along to the talk to learn about how well the models did and whether you can predict somebody's Myers-Briggs personality type with emojis, and what you can learn about people from the types of emojis they use, amongst other things. So that's it. Thank you.
Is the speaker in the house or online? No? Okay, we're going to skip. And it might be that the next one, they are also not present. Oh, no, it's not you, right? No? Okay, we are going to skip.
Hello, I'm Melindy. Our paper explored the effectiveness of generative models for genetic information extraction. We used 3 multilingual datasets to explore named entity recognition, relation extraction, and end-to-end information extraction. We used GPT 3.5 Turbo as our model and provided instructions via a manually crafted prompt library. Our prompts included fixed values for the instruction, annotation guideline, and the overview of the output format for each of the tasks. We varied the number of examples embedded in these prompts to explore the effectiveness of the model. We found that few-shot prompting leads to optimal performance across tasks for extraction of genetic information. We also observed 2 types of hallucinations, namely fabricated and over-generated instances. We observed that adding more examples in the prompts lead to a reduction in these hallucinations, hence less shots, more hallucinations, and inverse alcohol effect, if you will. Thank you.
Okay, we're going to skip to the next one, I guess. So then the last one session 6.
Hello. So I'm organizing the shared task for 15 years. So this is the 15th ALTA shared task. Has been happening once every year. And you can see all the different topics over there has been changing a lot. And this year is going to be evolved from last year's competition. Last year was about identifying automatic genetic text or human genetic text. Now we're going to have the hybrid detection in which the same test could could contain human or machine generated text. I don't know, this is not working well. So, okay, so I will talk about the details in the presentation tomorrow. This is a winner, as you can see there. They will see the results tomorrow, so I'm not going to say anything else now. I will just say that we have 3 baselines, and they all beat the two baselines, and the last one, the most complex one, was a bit more difficult to beat, but still, I think it was a very good shared task.
Thanks. So I think that we don't have this there. Oh, just turn it on. Okay. So we are going to skip, and this should be the last one.
Hi, me again. I'm back. So this is really largely a student project led by Joel Thomas. And the conceit for this, our thesis was, can you win the shared task using only traditional models, using an ensemble of classic models, so not a transformer-based model in sight, not a large language model in sight. That was the challenge we set ourselves. And the answer to that question is no. but you can have a lot of fun. So I will tell you about our system and the different models that we trained. So we had a really simple word count model. We had a stylometric model, really classic thing. We used some readability metrics and then some slightly more advanced models that had used part of speech models and one that I developed called information theoretic model, and then a couple of different stacking schemes for these. So to find out the results, to find out how well we did, you'll have to stay right until the very last talk of the conference and hear about that. Thanks.
Well, that's it. Thanks for all the presenters. Another big round of applause.